Have you ever wondered how our incredible planet came to be? Join us on a journey through time to uncover the fascinating story of Earth's formation. Our story begins approximately 4.6 billion years ago, when Earth formed from a massive, spinning cloud of gas and dust. This was a process driven by gravity, known as accretion. Imagine a colossal cloud of cosmic dust and gas. Even before our Sun and Earth existed, scientists believe a supernova, a powerful explosion from a dying star, disturbed this cloud, causing it to begin collapsing inward. As this massive cloud collapsed, it wasn't just falling in on itself. It started to spin faster and faster, eventually flattening into a gigantic disk we call the solar nebula. The force of gravity pulled most of the material to the very center of this spinning disk. Here, the pressure and heat became incredibly intense. Under these extreme conditions, hydrogen atoms began to fuse, forming helium and releasing an enormous amount of energy. This monumental event marked the birth of our Sun, igniting our solar system. With the Sun formed, the remaining dust and gas in the spinning disk didn't just disappear. They began a fascinating process of crashing into each other and sticking together. This process, called accretion, took millions of years. Tiny particles grew into larger and larger clumps, eventually forming asteroid-sized, planetesimals, and then Mars-sized, protoplanets. Gravity played a crucial role, continually pulling in more and more material. One of these growing rocky bodies, through countless collisions and accumulations, eventually became our early Earth. The early Earth was far from the calm planet we know today. It was a fiercely hot, molten fireball. This extreme heat came from the constant, violent collisions with other space debris and from the decay of radioactive elements within the planet itself. During this incredibly hot period, the Earth began to differentiate into distinct layers. The heaviest materials, like iron and nickel, sank to the center to form the core. Lighter materials rose to form the mantle and a thin, fragile crust on the surface. It was also around this time that a massive collision with a Mars-sized object is believed to have ejected enough debris into orbit to form our moon. As the intense bombardment from space gradually slowed, the Earth's surface began to cool. This cooling was crucial for the next major transformations. Volcanoes across the planet's surface became highly active, releasing huge amounts of gases, including water vapor, carbon dioxide, and nitrogen. These gases created Earth's primitive atmosphere. As the planet cooled further, the water vapor in the atmosphere condensed into clouds, and then it rained. For millions of years it rained, filling the low areas and forming the vast oceans we see today. Some water also arrived from icy comets and asteroids. With oceans established, the next significant chapter in Earth's story involved the emergence of land and, most importantly, life. Underwater volcanoes and the powerful forces of tectonic activity eventually pushed up land masses, creating the first islands and eventually the continents. This movement continues today through plate tectonics. Billions of years ago, simple life, like bacteria, emerged in the oceans. These early life forms began using sunlight to make food through photosynthesis, a process that released oxygen. Over time, this transformed the atmosphere into the oxygen-rich air we breathe, making Earth truly unique. From a cosmic cloud to a vibrant, life-sustaining planet, Earth's journey is a testament to the powerful forces of the universe. What an incredible story!